Hello everyone, my name is Asif Jamil and this is the audio assignment for Apache Spark. So, what is Apache Spark? Apache Spark is one of the hottest new trends in the technology domain. It is the framework with probably the highest potential to realize the fruit of the marriage between big data and machine learning. Apache Spark is an open source analytical processing engine for large scale, powerful distributed data processing and machine learning applications. Spark is originally developed at the University of California, Berkeley's and later donated to Apache Software Foundation. In February 2014, Spark became a top-level Apache project and has been contributed by thousands of engineers and made Spark as one of the most active open source projects in Apache. Spark is an Apache project advertised as lightning-fast cluster computing. It has a thriving open source community and is the most active Apache project at the moment. Spark provides a faster and more general data processing platform. Spark lets you run programs up to 100 into faster in memory or 10 into faster on disk than Hadoop. Last year, Spark took over Hadoop by completing the 100 terabytes Daytona Gray Sort contest, 3 into faster on 1/10 the number of machines, and it also became the fastest open source engine for sorting a petabyte. So, what are the features of Apache Spark? There are various features, some of them are noted below, like memory in memory computations, fault tolerant, least evaluation, cache and persistence. It also supports ANSI SQL, etc. Apart from all of these, there are various additional key features of Spark, like they currently provide APIs in Scala, Java, and Python with support of other languages on their way, and they integrate well with Hadoop's ecosystem and data sources, HDFS, Amazon S3, Hive, etc., Cassandra, etc. And they can run on clusters managed by Hadoop, Yarn, or Apache Mesos, and can also run standalone. Okay, so what are the advantages of Apache Spark? Spark is a general purpose in memory fault tolerant distributed processing engine that allows you to process data efficiently in a distributed fashion. Applications run on Spark are 100 into faster than traditional systems. You will get great benefits using Spark for data ingestion pipelines. Using Spark, we can process data from Hadoop, HDFS, AWS, Databricks, Azure, and many file systems. Spark also is used to process real-time data using streaming and Kafka. Using Spark streaming, you can also stream files from this file system and also stream from the socket. Spark natively has machine learning and graph libraries. Now, talking about the architecture of Apache Spark works in a master slave architecture where the master is called driver and the slaves are called workers. When you run a Spark application, Spark drivers create a context that is an entry point to your application, and all operations, transformations, and actions, etc., are executed on worker nodes, and the resources are managed by cluster manager. Many Spark programs revolve around the concept of resilient distributed dataset (RDD), which is a fault-tolerant collection of elements that can be operated on in parallel. Spark context resides in the driver programs and manages the distributed data over the worker nodes through the cluster manager. The good thing about using PySpark is that all this complexity of data partitioning and task management is handled automatically at the back, and the programmer can focus on specific analytics or machine learning job itself. Now, there are various Spark modules like Spark Core, Spark SQL, Spark Streaming, Spark MLib, Spark GraphX. Talking about one of the prominent Spark Core is the main base library of the Spark, which provides the abstraction of how distributed task dispatching, scheduling, basic input-output functionalities, and etc. Spark Core is the base engine for large-scale parallel and distributed data processing. It is responsible for memory management and fault recovery, scheduling, distributing and monitoring jobs on a cluster, interacting with storage systems, etc. Now, resilient distributed data set. Let's talk about this. Spark introduces the concept of an RDD, resilient distributed data set, an immutable, fault tolerant distributed collection of objects that can be operated on in parallel. An RDD can contain any type of object and is created by loading an external dataset or distributing a collection from the driver program. RDDs support two types of operations. Transformations are operations such as map, filter join, union, and so on that are performed on RDD and which yield a new RDD containing the result. Actions are operations such as reduce, count, first, and so on that return a value after running a computation on an RDD. Transformations in Spark are lazy, meaning that they do not compute the results right away. Instead, they just remember the operation to be performed and the data set to which the operation is to be performed. The transformations are only actually computed when an action is called and the result is returned to the driver program. The design enables Spark to run more efficiently. For example, if a big file was transformed into various ways and passed to the first action, Spark would only process and return the result for the first line rather than do the work for the entire file. By default, each transformed RDD may be recomputed each time you run an action on it. However, you may also persist an RDD in memory using the persist or cache method, in which case Spark will keep the elements around on the cluster for much faster access the next time you query it. Spark SQL. It is a Spark component that supports querying data either via SQL or via the Hive query language. It originated as the Apache Spark port to run on the top of Spark in place of MapReduce and is now integrated with Spark Stack. In addition to providing support for various data sources, it makes it possible to weave SQL queries with code transformation, which results in a very powerful tool. Below is an example of a Hive compatible query. Now, Spark Streaming supports real-time processing of streaming data, such as production web server log files, example Apache Flume and HDFS/S3, social media like Twitters, and various messaging queues like Kafka. Under the hood, Spark Streaming receives the input data streams and divides the data into batches. Next, they get processed by Spark Engine and generate final streams of results in batches as depicted in the figure. The Spark Streaming API closely matches that of the Spark core, making it easy for programmers to work in the worlds of both batch and streaming data. Next comes MLib. MLib is a machine learning library that provides various algorithms designed to scale out on a cluster for classification, regression, clustering, collaborative filtering, and so on. Some of these algorithms also work with streaming data, such as linear regression using ordinary least squares or k-means clustering, and more than the way. Apache Mahout, a machine learning library for Hadoop, has already turned away from MapReduce and joined forces on Spark MLib. Next is GraphX. GraphX is a library for manipulating graphs and performing graph parallel operations. It provides a uniform tool for ETL, exploratory analysis, and iterative graph computations. Apart from built-in operations for graph manipulation, it provides a library for common graph algorithms such as PageRank. Apart from RDD, the second key data structure in Spark framework is the data frame. If one have done work with Python pandas or R data framework, the concept may seem familiar. A data frame is a distributed collection of rows under named columns. It is conceptually equivalent to a table in a relational database, an Excel sheet with column headers, or a data frame in R/Python, but with richer optimizations under the hood. Data frames can be constructed from a wide array of sources such as structured data files, tables in hives, external databases, or existing RDDs. It also says it also shares some common characteristics with RDD, like immutable in nature and lazy evaluation, which means that a task is not executed until an action is performed. Distributed RDD and data frame both are distributed in nature, etc. Now, talking about advantages of data frame. Data frames are designed for processing large collections of structured or semi-structured data. Observations as Spark data frame are organized under named columns, which helps Apache Spark to understand the schema of a data frame. This helps Spark optimize execution plan on these queries. Data frame is Apache Spark has the ability to handle petabytes of data. Data frame has support for wide range of data format and sources. It has API support for different languages like Python, R, Scala, Java, etc. Now, concluding, to sum up, Apache Spark helps to simplify the challenging and computationally intensive task of processing high volumes of real-time or archive data, both structured and unstructured, seamlessly integrating relevant complex capabilities such as machine learning and graph algorithms. Spark brings big data processing to the masses. That's it for today. Thank you.